Hello everyone. Today we're going to talking about linked lists, and I think most of you still remember it in some way or sort. But this is going to be like a brief review about it. And again, I will try to post some question and challenge later on Facebook group. And please participate if you can do. Just show off your ideas, and I don't know. Even some comments about the video is still very useful for me. Okay, so linked list, what does this mean? Like, I guess you still remember these images. I used the same images with the slide that I used last year. So it's a sequence of data. It's simply a sequence of data. But the thing that make it differently from array is that it works like a link which contain item in each node. Okay, so this one is called node, and each node gonna have the way to connect itself to the other. That's the way linked list gonna work. So linked list also simply have like structure of the node, that it should be some kind of data structure that have a part of data and also part of pointer here. This pointer need to link itself to the other node, and this one also data and pointer, and then link itself to the next node. This is a simple structure of it. And you might say that, okay, we just have to create one struct or def one struct, and then a part of it is gonna be data, either it's gonna be integer, string, or complex structure, and then I need to have one pointer in the end, and that pointer should point it out to the next node. So basically, normally we used to design and create the pointer variable of each node to be name it with next. Okay, so next will point to the next node, and if this one is last node, it should point to now, right? Point to nothing. However, if we create the structure like this, then from the starting point, we don't know like how to point out where is the first node. If we don't know where the first node is, then we didn't know how to, recall this data structure in the memories. So without any means, we need to have one pointer here, which is normally called head, that represents the head node of data structure of the linked list. And basically, this pointer is gonna be the main pointer that you use to point out where the linked list is, or how you're gonna call the linked list itself. So basically, you call it by head, okay? And then you might say like, okay, we just need this, and it's gonna be complete pictures of linked list itself. But in the same time, it's gonna be a little bit good if we have the tail pointers at the end. Why we need tail pointers, you may ask. And the basic idea that we need the tail pointers, it simply means it's gonna be faster for you to add new node to the list if you have tail pointer point out where the last node is. Why? Think it this way, okay? If you doesn't have tail pointer, what will happen if we remove out tail pointers and we would like to add new node? Okay, we call function add node. How this add node gonna work is it need to call the pointer at head, right? And check that, okay, the node that head pointed to still have next, that is not now yet or not. Okay, check if not now. Then the temporary pointer have to switch out to be next to point out to the second node, right? So temp will ship here, and then it check again that if temp dot next not equal to now, then the temp should move and check again. So that is the complication that happens when you're going to add new node without the tail pointers. So you need to search through the list until you find the last node, and then you can add new node over there, which is going to be much less effective. So the best way to do is you remove out this idea, and then wise man in the past just simply said like, okay, we need one pointer here called tail, and this one gonna point to the last node. So whenever you call function called add node, what add node do is simply check tail pointer where it is, and then change next of the tail to new node, right? And this one still point to now from the creation of the node itself. Then what does it do later on? It change tail to point this node again. So basically the big O of this one is going to be just 2. Okay, you change the pointer, the next pointer of last node to point to new node, and then you change tail pointer to point to new node as well. Then it's going to be much faster and more effective in comparison to the ideas of linked list without tail pointers. And that's why this one, even though it can work without tail pointers, I still highly recommend you to create the linked list with tail pointers because it's much more effective this way. Okay. So what is double linked list? In this one, you can see that the direction of searching always be this way, right? You're searching from head to tail, just that way. However, if you want to create the list that can transversal in the 2-directional way, which is called double linked list, it's this one. Simply speaking, you just create the node that have 2 pointers. One point to the next, another one point to the previous. Every pointer that point from one node to tail, okay, from the direction from head pointer to tail pointer. If the pointer of that node point in the direction from head to tail, we're gonna call that pointer as next pointer. So simply means it's point to next node. Okay. However, every single pointer that point from tail direction to head direction, we're gonna call it previous pointer. And then by this structure, you can see that, okay, it means that the next pointer of the last node is have to be null, right? In the same way, the previous pointer of the first node also should be null. What is going to be the good point about this one? For this one, you have more flexibility, right? It means you can insert new node into direction. It can be either insert from the front or insert in the back, right? And then in the same time, you have more flexibilities if you would like to call the data within linked list without have to research it again. For example, if we go back to this one, okay, if we go back to this example, okay, if we go back to this example, what will happen that we try to call data in this linked list. So basically, we need to have a temp data like pointers, and if temp search through the linked list to the last one, and then we call the data, then what happens if we still want to access this data later on? Or in simply speaking, how we gonna recall data backward from tail to head? In this example, what happens is you need to change temp back to the starting point of the linked list again, right? Because there is nowhere else you're gonna do. You need to change temp equal to head again, which is point to this one, and then you search through linked list again until temp move to the exact node that you want to recall the data. So you can see like whenever you want to search backward, it's going to be extremely difficult to do by one-way linked list. Even though it saves a lot of memory to retain the pointer of the previous one, if the node that you have is like you have like million nodes connect to each other. However, it's going to be pretty difficult to create algorithms to search through or sorting or do whatsoever. But this one, the idea is that it's going to help you when you have previous and next. It means you have flexibilities to move back and forth between each node. And you can revert the node, you can delete the node in between and whatsoever. That's going to be very useful. Okay, so in come to the basic operation that you should have, since linked list can be extremely flexible, it's always used because the dynamic size that it has. Okay, so basically it should be able to insert at any position, right? But as I mentioned before, that if you have one-way linked list, okay, if you have one-way linked list and you want to insert any node in any position, the way you're gonna do is you count, right? You count from here and you start counting 1, 2. Okay, this is the point that you want to insert new node. What you have to do first is you need to point this node, like the new node, to the next first. Why? Because if we do it this way, if we starting from, okay, I change node 2 dot next equal to this node, okay, new node. What happens is point this way, and then somehow there is nothing in the memories that work as a pointer toward this node. Then this means it's impossible for you to point the new node back to the chain of the linked list, right? This one is impossible, totally impossible. You cannot do that. That's why the proper way that you're gonna do is you're gonna assign new node. Okay, first new node dot next equal to node 2 dot next first. Okay, this one is node 2. If you do it that way, then you still have two pointer point at the end of the chain, right? And then what happened next is step 2. You assign node 2 dot next equal to new node. Then it means you remove this link and point this one in. That is gonna work, because by this sequence you can, you know, like you still have everything that point out to each point at the memories, and this is gonna be fine. But for double linked list, what gonna happen is gonna be a little bit different because you have more flexibility to do so. Okay, if you have double linked list and you want to insert new node, since you have two pointer here, one point to the next, another one point to previous, then you have flexibility to start by the previous node or you start by the next node. However, just keep in mind that you shouldn't, okay, you shouldn't cut out these two pointer at the same time before you assign this new node back to the chain. Okay, because if you cut these two out immediately before you assign this new node to the front or to the back of the linked list, then simply mean there's nothing in the memories that can point out where the chain of linked list is. Okay, you just have to do either, okay, point this one to the front and point this one to the back, and then you start to remove and point this one back here and point this one back there. That's one way to do that. Or you can do something like more sequentially. For example, that you starting from, like, you still have this link, right? You starting from remove this one, the previous of the last node, to point to new node, and then you link the previous of new node back to the front of the chain. Then you remove the next of the front of the chain back to new node, and next of this one back here. Okay, you can do like any way you want, but remember that you need to have something that can point out to another pointer, right? So the safest way that you can do is that, okay, first of all, you made this one, so I would use this color. So first you might say like new node dot next equal to node 3, right? So you point this one first, and then second you might say like new node dot previous equal to node 2. Okay, so you create a link first. Then what else you're going to do? Third, you start to remove the chain, right? So you change this one first, you change node 3 dot previous equal to new node, and then 4, you change node 2 dot next equal to new node, which is mean you change this one to point here, and you change this one to point here instead. So that's the way around. Like, you can do any way that you want, and you have more flexibility this way for double linked list. Okay, come to deletion. So for the deletion, is simply mean that if you want to cut out one node out of the chain, how you gonna do that? Okay, we're gonna go for single linked list first. Then what we gonna do? Okay, if we want to remove this one out, then simply mean that you need to change node 1 dot next equal to node 2 dot next first, right? Because you want to connect the chain. What should we do here? Can we do something like this? Like, first we assign node 1 dot next equal to node 2 dot next. Can we do that? Okay, if we do it this way, it simply means that we cut out here, right? And we change this one to connect to the third one. The problem is, now how can you call the second node? How can you remove this node out of the solution? Impossible, right? So simply mean that you cannot do it this way for single linked list. Okay. Then what you should do is you need to use temporary pointers to point to the last node first. So you need to create temp equal to node 2 dot next, right? Then it means now they have temp here, point over there, and then you delete node 2, right? Then after you delete node 2, what happens? There's nothing that node 1 dot next point to, right? Then what you have to do is the third step, that you change node 1 dot next equal to temp, which is simply mean that you change this one point to the back of the chain. So that is the idea to create the deletion algorithm for single linked list. How about double linked list? What you should do in double linked list to remove this node? So you have a lot of things that you can do so far, right? And the idea is mean that you can do something like tidy it up a little bit by I just given like one of the possible example. Okay, you can do like in 2 or 3 way, I guess, but this is one of the possibilities. Okay, then what you can do is, okay, you have node 1 and then you know node 3. Since it is double linked list, you know it for sure. Okay, you want to delete this one, you can transversal to this one and this one first, right? And what you can do is simply like you change node 1.next equal to node 2.next, which is mean that you remove this one and make it point to the last node. Okay, then what else you can do? You can start by deleting this one, right? Then it's gonna be a little bit hectic that you need to know that, okay, this one is equal to this one dot next. But then the simplest way to do and make less confusion, but it's not very effective, is you create temp pointers. Temp pointers equal to node 2 dot previous, and then you delete. Okay, this way temp point here, right? And then you again delete node 2, which is you can do it because you have pointer from node 3 that point back here, right? So you can delete it here, and then number 4 you can make node 3 dot previous equal to temp, which is mean node 3 dot previous will point back to node 1. And that's it. That is less confusion version of deletion of double linked list, but not that very effective. If you want to, you can post your idea how to make it more effective in the comment of the video. And this is the video for today as a recap for the linked list. Then the next one, I would like to make the short video like this and talking about list in Python, how it's different from linked list, how it's different from array, and how we can like modify the or use the benefit of each algorithm combined together and use it in the same application. Okay, then thank you for today. I'm talking so long. Bye bye.